Hello, Algebra 2. Hope you guys are having a great day. Um, Today we're going to talk about solving quadratic equations with graphing and factoring. So there's going to be a couple different words that I use in this video that are kind of confusing, like what the difference is between the three of them. So I want you to get used to the three words because they're all really similar to the same thing, but they're not quite exactly the same thing. So pay close attention to those. Anyways, practical example. All right, say for example we have another soccer ball getting kicked through the air, right? And if we wanted to find the height of the ball, maybe the max height, we'd be looking for the vertex. But what if we wanted to know the time at which the ball landed or how long the ball was in the air, right? Those are different questions you can ask about the ball, right? So say, for example, you know that the height in feet of a ball after t seconds can be modeled by the following function. H of t equals negative 16t squared plus 32t. Okay, and the graph of it is shown to the right. So basically, all that means is that height, h, is a function of time, t. And so my x variable, or my independent variable is t, and my dependent variable is h. Okay, so let's label that on our graph. All right, so basically we're essentially thinking about, this is not the actual ball, like this is not the movement of the ball, because my x-axis is not horizontal distance, so that's not something that you're observing right now. So just keep that in mind. Anyways, it's just a graph that represents, as time goes on, how high is the ball. So here's the question, right? When the ball hits the ground, what is the value of the function h, right? And if I'm hitting the ground, right, my height, regardless of what the time is, if the ball has hit the ground, my height is 0. So that's there and there, right? And the first one is probably when you initially kick the ball, right? It's leaving the ground, and then it leaves the air, and then it comes back down, and then it hits the ground again, right? And so when h of t equals 0, that's when the ball has hit the ground in this case. All right, so here are the three vocab words that I told you about that are kind of like really similar to almost the same thing, but like not quite. Okay, a 0 of a function, that is the value of your independent variable, so the value of x, or values of x, that make the function, or y, 0. Okay. All right, so the values of x that make the function equal to 0. Okay, this is another way to write it. And basically the squiggly brackets mean like the set of. So this means like the set of all x's such that f of x equals 0. So all the x values that make the function equal to 0. It means the same thing. It's just written algebraically instead of in words. Okay, so then the next thing is x-intercepts. Right, your x-intercepts are graphically the values of x that make the function 0, right? So it's where the function crosses the x-axis. Now a lot of times those are the same thing, because like if we go back up to this graph, for example, when I cross the x-axis, my function is equal to 0, right? So at that x value, 2, right, when x equals 2, I have an x-intercept, and I also have a 0 because the function h of t is equal to 0 at that point. Okay, so when are they not the same? Well, basically it's not the same thing if, for example, if I have a parabola that looks like this, where it doesn't actually cross the x-axis, I don't have any x-intercepts. right? Because I'm not crossing the x-axis. But I do have zeros. They're just imaginary. So they don't show up on the graph, but there are actual solutions that make the function 0. And okay, actually the next vocab, roots of a function, it should actually say roots of an equation. It doesn't really make sense to have roots of a function. Roots of an equation. Okay, and the difference there is that the roots of an equation are the values that solve the equation. Okay, so like I could give you, 2x plus 1 equals 5, and you'd solve for x, and you get x equals 2, and the root of the equation, which is the same thing as the solution, is 2, right? Because that's the value that makes the solution, that makes the equation true. All right, so we kind of talked about the difference a little bit. Roots of an equation, you start with an equation and you just solve it. The 0 and the x-intercepts are more related to a function in a graph. And then all x-intercepts are zeros, but not every 0 is an x-intercept. So that's what I would say is the difference between all those things. All right, so if you have an object thrown or launched in the air, like I throw something across the room, the general function that approximates the height with respect to the time that has passed is the following. And this is going to be something that's useful in the future and for problems that are using projectile motion. Okay, so we're going to do a couple examples. If you'd like, you can stop it now, try them, check your answers. Say, hi, buddy. Hi, buddy. Hello, what's up? Yeah. You're going to do some math with us, huh? Okay, sounds good. Okay, so go ahead and pause it and try those. All right, example number 1. Find the zeros of the following function using a graph, table, and then using algebra to check it. Okay, so we have 3 different ways to find zeros. First one is, let's graph it. All right. Actually, let's make a table to graph it, because then we can kill 2 birds with 1 stone. So I'm going to make a table, x and y, and let's start plugging in some values of x. Alright, so I started by picking a few values of x. I picked -2, and then I plugged that into the function, got 9, plugged in -1, and I got 0. So automatically I stopped, because that's a value of x for which the function equals 0. So we know that one of the zeros is -1. So let's just keep that over here on the side, just so that we remember that that's one of our zeros. And so keep picking a few more values of x. I'm going to go 0, 1, 2, and see how we do there. All right, so these are the points I got. -2, 9, -1, 0, 0, -5, 1, -6, 2, -3, and 3, 4. So a parabola can only have at max 2 zeros. It might have 1 0, or sorry, I'm using the wrong word. X-intercepts. It can have at max 2 x-intercepts, 1 x-intercept, or 0 x-intercepts. So, right, a parabola that has no x-intercepts looks like that. One that has 1 x-intercept just touches the x-axis. And then if it goes all the way through, it has 2. So in this case, right, we can graph it, and we can find the zeros. -2, 9 is somewhere there. I'm doing this totally approximate. 0, 0, and 0, -5, 1, -6, 2, -3, and 3, 4. Okay, so your parabola looks something like that, and it's not going to skip the x-axis, so you know that there's another 0 here, and it must be in between 2 and 3. So then you can start picking points in between 2 and 3. I would go by maybe a half, then a quarter, and kind of figure out where it is if you have to do it graphically or with a table. Otherwise, algebraically is a really great way for it to work as well, and then you get the exact answers. So that's more ideal, but sometimes you don't get that option. So go ahead, try a few values between 2 and 3. I'm going to try 2.5 and see what happens from there. So it conveniently turned out that 2.5 is actually the 0, so that was nice. So we know that the zeros are -1 and 2.5, right? -1 and 2.5, and we did it using a graph and a table, and then we would have to do it using algebra to check it as well. Okay, so let's do that real quick. All right, so here's our function f of x equals 2x squared minus 3x minus 5. So the question is, how do we solve this algebraically? Well, in order to find a 0, the function needs to equal 0. So first step is we set f of x equal to 0. All right, next step is if it's not factored already, you want to factor it. Okay, so if you forgot how to factor a value, a quadratic with a number in front with an a value that's not 1, make sure you kind of review these steps. But remember, your 2 goes and visits the 5, and then you factor that, and then you bring the 2 back, and then here's bringing the 2 back into both, and then you divide it out of one of them. So I end up factoring this to be 2x minus 5 times x plus 1. If you factor it a different way, that's fine, as long as you get this result. Okay, so once it's factored, then now you've got 0 equaling something times something else. And the thing is, right, the way that 0 works, right, anything times 0 is 0, and 0 times anything is 0. So if this equals 0, if 2x minus 5 equals 0, then I have 0 times x plus 1, and that whole thing equals 0, and it solves the equation. If, on the other hand, this is equal to 0, x plus 1, if that equals 0, then I have 2x minus 5 times 0, which equals 0, which is what we want it to equal, because that's on the left-hand side, right? We need the statement to be true. So, anyways, what that means is there's 2 solutions. So you actually take the 2x minus 5, set it equal to 0, take the x plus 1, set it equal to 0, and you get 2x minus 5 equals 0, and x plus 1 equals 0, and just solve. So you add 5 to one side, divide by 2, you get x equals 5 over 2, which is 2.5. And then you can also subtract 1 from the other equation, you get x equals -1, and in which case you get both of our solutions. So you have 2 answers, 2 zeros, 2 x-intercepts in this case. Next question, you end up doing the same thing, but it's a different question, right? It starts with an equation. It says find the roots of the equation, and that just means find the values of x that solve this equation. But here's the thing, we don't have it equal to 0 first. So in order to be able to do what we did in the previous one, we have to make it equal to 0. So add 16 to both sides, equals 0, and then we just factor that. So what times what equals 16 but adds to 8. So that would be 4 and 4, right? So this ends up factoring to x plus 4 times x plus 4 equals 0, and you have to set each one equal to 0. In this case, you get x equals -4 twice. So you only have actually one x-intercept, but there's 2 solutions. It's -4 twice. Okay, next one. Okay, so this is a different direction, right? Write a quadratic function in standard form that has zeros 2 and -5. Okay, so if you know that the zeros are 2 and -5, then you can work backwards. So x equals 2 and x equals -5 would be our solutions. So we need to figure out what the factors would be. So I subtract 2 to the other side, so I get x minus 2 equals 0, and x plus 5 equals 0. And so those are my 2 factors. I get x minus 2 times x plus 5. And then if I want it in standard form, I have to multiply it out. I get x squared plus 5x minus 2x minus 10, and then simplify, There's the answer to 3, and check the answer to 4.